Good evening. My name is Pavitran Rajendaran. Let me introduce my teammates. Ahmad Syameel being Muhammad Muslim, Alif Haronudin Ismail, Hiang Chuan. I'm going to present about the title is Anti-Collision Detection. The purpose of doing this anti-collision detection is to measure the distance between the vehicle and any surrounding object or vehicles. By continuously monitoring the distance, the system can assess the risk of collisions and take appropriate measures, such as alerting the driver like the buzzer sound and the LED light will pop up. System can detect and track the movement of the object, allowing them predict the potential collisions before they happen. Prevent accident by detecting potential collision and taking all action to avoid them.
Assalamualaikum and hi, my name is Syameel and I will present about the working operation of the anti-collision detection. I will present the system based on this flowchart. An anti-collision detection system using an ultrasonic sensor, IR sensor, LED buzzer and Raspberry Pi is designed to detect and alert the presence of obstacle and preventing potential collision. First of all, the system will start and initialize the sensors. Next, there were two sensors, which are ultrasonic sensors and IR sensor. In this project, we use both sensors to detect if there are any obstacle or object in front of the sensor. The first sensor is ultrasonic sensor. The ultrasonic sensor emits ultrasonic wave and measure the time it takes for the wave to bounce back after hitting an object. This time interval is used to calculate the distance to the object. We have set the distance based on the coding setup. The sensors will check if the value is below than 100 cm or not. If no, it will display the distance is safe. If yes, it will display too close might collide. Next, the buzzer will emit a sound and LED will blinking. And end. Besides, the second sensor is IR sensor. It will use infrared light to detect an object within its range. If no object within its range, it will display the distance is safe. If yes, it will display too close might collide. Next, the buzzer also will emit a sound and LED will blinking and end. That's all.
Hi, my name is Hiang Chuan and my number metric is B0221101168. Today I'm going to present about our anti-collision system coding by using Python. In our system, we have two input and two output. For the input, we are using ultrasonic and IR sensor. For the output, we are using LED and buzzer. So, for this part, we have to declare and define the GPIO pin for the input and output. So for the ultrasonic, for the pin trick, we will set it on pin number 27. For the echo, is on pin number 24. For IR sensor, is on pin number 17. And for the output, LED is on pin number 27. Lastly, buzzer is on pin number 22. So this is the declaration for each input and output on the GPIO. Next, this part is the coding for the ultrasonic to receive signal from outside, so that it has the delay time to receive the result from the sensor. And this is the calculation for the distance to the sensor. Lastly, this is the function, the conditional for the RR sensor and also ultrasonic. When the sensor detects something in front of it within less than 100 cm or the IR signal is activated, the LED and the buzzer will active, and the display will print out too close might collide. And it will print also the distance that been read by the sensor in 2 decimal places. And then else, if the sensor doesn't detect anything in front of it, the LED and the buzzer will deactivate, and the display will print the distance is safe, and also included the reading for the distance in 2 decimal places.
Assalamualaikum and good day to you guys. My name is Harun, and in this part of the video I will be showing how to use Raspberry Pi from flashing all the way to using it as your microprocessor. So next, open Raspberry Pi OS and then download the installer. Then after finishing download, you can install it and then open the imager. After the software is open, we can choose Raspberry Pi device based on what device we are using. In this case, Raspberry Pi 3. Then we can choose the Raspberry Pi OS, in this case 64-bit, which is the latest version, and then choose the micro SD card to flash the OS. And then accept all setting and we are done. Jadi untuk flashkan OS dalam Raspberry Pi, kita perlu ada micro SD card at least 8GB. Jadi sini 16GB. Jadi untuk flash perlukan adapter, SD card adapter. Masukkan micro SD dalam SD card adapter, dan adapter ni pun dicucuk dalam USB adapter. Dan kita cucuk. Jadi pada ni Raspberry Pi imager ni satu tools untuk kita flashkan kita punya Raspberry Pi OS, nak flashkan OS dalam micro SD card. Jadi kita pilih Raspberry Pi device tu based pada model kita, pakai Raspberry Pi 3. Dan OS pakai Raspberry Pi OS 64-bit, menggunakan Debian bookworm sama desktop. Dan storage tu location micro SD card tadi 16GB. So next, once the flashing are done, we can use the SD card to boot the Raspberry Pi. Selepas write successful, boleh cabut. Then kita boleh cucuk SD card masuk balik dalam slot SD card Raspberry Pi. Okay, jadi kita boleh try dan boot dengan monitor. Jadi lepas flash tadi, kita try boot. Jadi SD card tadi dah ada Raspberry Pi OS Debian. Terus masukkan power cord, and next HDMI display port. Jadi dah masuk, dah booting. Jadi sekarang tinggal set up Raspberry Pi OS. Jadi pilih country, Malaysia, language Malay, Tanzan, Kuala Lumpur. And next, jadi into username. Masuk wifi. Jadi saya ready dan boleh restart. So this is all the necessary files in order for the Raspberry Pi to be working like a charm. Next, to check virtual memory, first kita open terminal, then kita typekan vm start. To check version Python dia, first kita open terminal, kita type in Python. Jadi situ Python 3.11.2. Jadi ini coding untuk LED sebagai output, RPGPIO, then import time, set mode dan set warning. Kemudian set pin 4 sebagai LED sebagai output. Dan dia akan print blinking, maksudnya dalam 60 second dia akan run output. LED 1 dia akan menyala, dan delay 1 second, dan output LED kosong dia akan malap dan delay 1 second. Okay, cuba run. Press button untuk kita guna GPIO sebagai analog pin. Dia boleh try run. Sekarang dia tulis button press. Ini sebab gunakan button jenis latch switch. Dia hold position dia. Jadi bila toggle switch tu, you can print OK. Assalamualaikum. Now I'm going to show you guys how to connect Wi-Fi on the Raspberry Pi. You can see there's a Wi-Fi icon. Click here, and then select any of the Wi-Fi, any of your Wi-Fi, and then it will ask for authentication. Then fill in the password, and then can connect. Show you that you are now connected to the Wi-Fi network. So use the example that we are connected to the internet. We can try to open Chromium and try search something. So as you can see, we are connected to the internet. Assalamualaikum and hi. Today I'm going to show you guys about the demonstration of anti-collision system using Raspberry Pi 3. So let's take a look at the components first. Okay. So first thing, we have two sensors, ultrasonic sensors and IR sensors. So these both sensors used to determine the distance from one vehicle to another vehicle. Then we have the indicators, which is LED and buzzer. So both of these used to indicate the user about the surroundings based on both of output of the sensors. So let us test run code. So as we can see here, the terminal shows the distance, and it gives the condition at what the vehicle is at. For now, the distance is safe, and it shows the distance in centimeters, which is the nearest obstacle is 56 centimeters. So let us test run if there is any vehicle nearby. So we can mimic by using our hand and then use to indicate there is obstacle nearby. So the ultrasonic measures the distance and then registers it, and it says too close. Too close might collide, and gives the measuring, which is less than 10 centimeters. So next, let us test the IR sensor. So IR sensor will also give the signal if there is anything close with the system, and it also shows too close might collide. So that is all for the demonstration, and then let us talk about what happens if certain codes are modified. What happens to the system? So first thing first, this is the GPIO pins. This is used to set whether what pin is used at what sensors or what devices are used to connect with what pin. So if we change certain pin with any other numbers, it will not register, or it will give the wrong value. Yeah. So next is the function distance. So this is a fixed function or fixed equation. We cannot change any of this code because it is what it is. So if we change any of this value, the ultrasonic sensor will give the wrong measuring, thus resulting in a fail or inaccurate measurement of the distance. So next is the detect collision, the conditioning. If we change, for example, the distance, if the distance is below, in this case the distance is below 10, it will turn on the LED and buzzer. But we can configure it to set, for example, 25. Then the system will ring the buzzer and turn on the LED when the distance is below than 25. We can configure any value, for example 100 or any values. So the users have the access or have the flexibility to set their own extend their own target or extend their own distance to indicate what is danger or what not. Okay, and then we can also set we can also print what value we want to show. So in this case, we use this to show the value distance, but we round up to the nearest 2 decimal. So that is all for explanation of demonstration and what are the things that will change if we modify the code. Thank you.
Raspberry Pi compatible sensors like ultrasonics or infrared sensors have limited range. They might not detect objects far enough away for high-speed situations. The Raspberry Pi is a capable little computer, but it's not a powerhouse. When it receives any data from the input sensor, it still can process in a short time, but when the Raspberry Pi want to process the image from the cameras, it can become slow. There is one of the weakness about our anti-collision detection system is ultrasonic and infrared sensors can be fooled by dust, rain, or other environmental factors. The sensors need to be clean to get the better detection results. Mostly, you will see the anti-collision detection system on the vehicle. This is because to ensure the safety of the driver and also the passengers. This system is so very important to prevent an accident occur while driving. It is quite complex for the new learner to learn on how to build anti-collision detection system. However, it can become easier when having a fundamental about electronics, programming and sensor calibration. By combining multiple sensors, such as LiDAR, light detection and ranging, for accurate distance and object shape detection, and cameras for object recognition and traffic light detection, provides a comprehensive environmental picture.